so dark, you don't wanna wait. You taking all these drugs just to numb all the pain. Do you feel okay? Do you feel safe? Do you wanna run away? Like, oh, I don't wanna die. Oh, just wanna feel alright. Oh, we can do this all night. Dance away our lives. Taking the pills she like. She drift away. Oh, she drift away when she's riding down the straight, going about 108. I fall away, oh I fall away, but I can't fall asleep, cause I just stay awake now. One in Miami, Tuesday I'm flying, drinking the bottle, running away, ain't no private. Why is you crying?
Okay, people. Let's see. Let's make sure this is working. Should still be working. Are we good? Are we good on sound? No, we're not good on sound yet. Wait, yeah we are. No, we're not. Yeah, we are. No, we're not. Yeah, we are. We good on sound? Maybe. All right, hang on. And make sure we're good there, and then we will begin, people. We will begin. We will begin. Hang on, I'm trying to remember the name of the thing I always use. There we go. Boop. Something kind of soft that can just kind of fade out in the background. Okay. Okay, alrighty. Okay, peeps, if you're here, it's math time. It's math time. Alright. Test is tomorrow. You can do it. You know what this is. We're going to get our review on. Let's turn the paper brightness down today. Let's go got a gray tonight. Actually, should we go blue? Nah, let's go gray. You want to go gray? Purple? Let's go purple. Brown? Gray? Let's go gray. I don't know. I feel like purple would be good. All right, let's do it. All right, if you are just now getting here, welcome. This is recorded on YouTube because you can go back and watch it at any time. Not all of you are going to be able to see this right here and right now because tonight is the night of Action Air, but tonight is also the night before your test. So I'm trying to give you something you can work with. If you see this later on, great. Look at it, use it. Listen, those of you who are using these videos for review, I'm glad you are. Let me teach you a study tip, and I'm going to really see about doing a study skills series of study skills workshops at the school for you next year, so we can really talk about how to learn. Okay, watching these videos is not going to help you. Watching the videos and pausing them, then working it is going to help you. Math and learning both require doing. So like watching will not help. Watching and doing will help beyond. Doing without seeing it done is hard. Watching and not doing is hard. Watching and doing is easy. Yeah! Okay, so you want to do both. Okay, you need both. If you do either or, it's going to be a bad time. So make sure you pause this video. Not necessarily during. You can watch it during, but then go back after and work it at your own pace. Or you can work it at your own pace as we go, okay? This is going to be kind of quick because it's 7:30 and I don't want to push too far into the night. So let's begin. Okay, all right. Most of you have a test on one of these three things. Squares. What did I title this thing? I titled it what you have your test on. Hang on. Fractions. All right, some of y'all still got the fraction thing going on. And combining like terms, all right? I'm going to spend a little bit on each. I'm going to give you some practice problems. It's up to you to go back behind it and work it. If you don't work these, tomorrow you're going to fry. You're going to fry. So, work it. All right, here we go. All right, remember that a square just really means something times itself, all right? I know that for many of us before now, when we said square something, or when we said, when we're used to seeing, hang on, sorry, I'm trying to get the software right. All right, when you're used to seeing 3 squared, right? Or when you see 3 and like a 2, you think 3 plus 2 or 3 times 2. That's not what this means. 3 squared does not equal 3 times 2, okay? No. All right? Put a slash through it. Yeah. Okay, no. All right? 3 squared means 3 times 3, because this number here is the number you're multiplying, and this number here tells you how many times to multiply it times itself. Okay, so what that means is 3 to the 4 would mean 3 times 3 times 3 times 3, because that is 3 4 times. 1, 2, 3, 4. Okay? Exponents are just instructions, and squares are just a form of exponents. Okay? The thing I want you to remember the most is the number that's in front is what you're multiplying, and the tiny number at the top is how many times you multiply it times itself. Okay? Take your time on your test. Take your time on your test and double check your test to make sure that's what you're doing. Double check on your test that you're doing this and not this. Okay? I'm gonna put scribbles through that. Not that. Okay? Not that. Okay? All right, here we go. Okay, so let's do a couple example problems on just that, okay? 2 to the 5th, 8 squared, and 10 squared, and 11 squared, okay? Take a few minutes and work that out, all right? Pause the video here if you want to work it now. If you don't want to work it now, fine. You can wait till after and then work it yourself. But pause now if you want to work it, okay? I'm getting ready to work it. All right, here we go. All right. 2 to the 5th is the same thing as, remember I said this number, so 2, times itself how many times? 5 times. So 2 times 2 times 2 times 2 times 2. Which should be, let's see, that's 1, 2, 3, 4, 5 times, right? Okay, great. The way I'm going to work this is like so. I'm going to go 2 times 2, which is 4. This is 2 times 2, which is 4. And I'm just bring this 2 up. 4 times 4 is 16. And 16 times 2 is 32. Okay, that's 2 to the 5th. All right. Hey, Shells. All right, let's go. Yeah. Don't forget, we got a meeting in the morning. Y'all. Meeting in the morning. Yeah, it's okay. It'll be fine. We're going to have breakfast. All right, so fine. For number 2, here's the number, right? And here's the number of times we're going to multiply it times itself. So fine, 8 times 8. Why 8 times 8? Because I got 8 here, and this is how many times? 1, 2. So 8 times 8 is 64. All right? Hopefully by now you picked up the pattern. This one should be 10 times itself how many times? 2 times, because you see that here. So 10 times 10, which is 100. Okay? And your last one, what's the number? 11. Okay? And 11 times itself how many times? 2 times. That's right. 11 times 11. Da-da-da-da. Done. Okay? That is how we're going to approach exponents. Okay? Now, the reason some of you asked me a lot this week, I don't get why it's called a square. I don't get why it's called cube. Let's go over that just briefly, then we'll go to square roots. The reason when you take a number and raise it to the second power, you know, the exponent of 2, the reason that it's called a square is because a square is 2-dimensional, meaning it goes up and down, left and right. It's flat. All squares are flat. Think about it. You've never come across a square that's not flat. Squares are flat because they're 2-dimensional. A cube is when you take a number and raise it to the third power, okay? That's called a cube because a cube is 3 dimensions, as in it's got up, down, left, right, up, down, left, right, and then above and below. Above and below. It's the third dimension, okay? All right? Technically, the fourth power should be called a tesseract, but we're not going to go into that. All we're going to say for now is these are just layman's terms. These are just nicknames, okay? These are nicknames. Like, my name is Michael, but everyone calls me Mikey, and I go by Mikey. Now, I don't really care what you call me. You can call me Billy Bob. I don't really care. I know who I am. But the point is, a square is the same thing as something to the second power, and a cube is the same thing as something to the third power. Okay? So whenever you see the word cube, it just means what number times itself 3 times. Whenever you see the word square, it means what number times itself 2 times, okay? Here's why that's important. Some of you really fried when you saw this. Cube root of something, okay? That just means what number times itself is that. So if I ask you what's the cube root of 8, I'm only asking what number times itself is 8. If you don't know, that's no problem. Start from 1 and go up. So fine, let's do it. Let's go 1 times 1 times 1. 1. 2 times 2 times 2. All right, 4 times 2. 8. Oh, da-da! Found it. 8. Okay? Cool. Let's try another one of these cubes. The cube root of 27. Let's start from 1 and go up. 1 times 1 times 1. 1. Okay? 2 times 2 times 2. Okay? 8. 3 times 3 times 3. Okay? 3 times 3 is 9. And 9 times 3 is 27. Hey! Okay? Remember when you're doing these that it's times, not adding time. So take your time. What I want all of you to do is work through your test, then go back and double check and make sure, just like I'm doing right now, that you're showing every step. No mental math out here. Hold on, let me write it in big caps for you. Those of you who've been to my class, you already know. No mental math. I will throw a banana at you. No mental math. Let me write it in another color. No mental math. Show me the work. Show me the work. Because if you show me the work, I guarantee you one of two things. You will get it right or you will see where it needs to be right. Always show me the work. Show me. Okay, anyhow. All right, so let's go on. Okay. All right, let's do another one. Let's go cube root. Oh, God, it's still big. Okay, cube root of 125. No problem. 1 times 1 times 1. 1. 2 times 2 times 2. Remember, pause me if you want to try this yourself. Okay, pause me. 8. 3 times 3 times 3. 27. 4 times 4 times 4. Go ahead and give it a shot. All right, 64. 5 times 5 times 5. Work it out on your own. Okay, hopefully this is what you did. 5 times 5 is 25. Bring down your 5. 25 times 5 is indeed 125. The cube root of 125 is 5. Because 5 times 5 times 5 is 125. Okay, so see how this goes backwards and forwards. Cube roots take you to the smaller number, and cubes take you to the bigger number. Square roots take you to the smaller number, and squares take you to the bigger number. That's where we're headed with all this, okay? All right, so let's look at a couple of things, all right? Let's practice some multiplication, and then we are going to talk about what to do about this rational and irrational thing too, okay? So hang tight. All right. Let's take the example 5 times the square root of 25 plus 2 times the square root of 9, okay? No big deal, all right? Here's what I want you to do. Do your square root first, and then we will do the rest. Remember that from now on in math, real quick, I'm going to draw this over here. Yink, yink. Remember that in math, from now on, when you see a number just sitting next to a number, it's not just chilling. That means multiply, okay? So you see 5 next to a 3, they ain't just chilling, just hanging out, like, it's multiplying, okay? We get multiplied out here. So 5 times 3 is indeed 15, okay? 7 times 3 is indeed 21, okay? What's that got to do with this? The same thing is happening here. This 5 is being multiplied by the square root of 25, okay? And this 2 is being multiplied by the square root of 9, okay? So what we're going to do is we're going to do the square roots first. So let's take it piece by piece. The square root of 25 is 5. Bring down your 5. The square root of 9 is 3. Bring down your 2. Okay? Do it all piece by piece. All right? 5 times 5 is indeed 25. And 2 times 3 is indeed 6. Okay? And ta-da, now you got 25 plus 6, and that's 31. Okay? This thing that looked really ugly at the start isn't ugly. Okay? It's not bad if you take it piece by piece. Look at this thing. It looks like a monster, but it's not. You just have to break it piece by piece. That's what I want you to do with yours too. Break it piece by piece. Okay? Let's try another one together, and then I want you to try some on your own. Okay? Try 5 the square root of 4 minus 10 square root 9. Okay? Same rules. All right? Let's start with the square roots. What is the square root of 4? 2. All right? Bring your 5 down. We haven't done anything with that yet. Bring down the minus. All right? What's the square root of 9? Okay? 3. Okay? Bring down your 10. Remember, if I'm going too fast, it's fine. Rewind it, pause it, and try it. Okay? 5 times 2 is 10. Bring down your minus. And 10 times 3 is 30. And 10 minus 30 is negative 20. And we are done. Just like that. Okay? Piece by piece and you'll be fine. Those of you doing this, hold up, let me put it in big caps. Y'all already know where this is going. You already know what's going. Those of you out there doing this atrocity, mental math, that's how you get crisscross. Stop all that mental math. I'm coming for you. Okay? I'm gonna show up to school Halloween with the Grim Reaper's outfit, and I'm gonna start swinging scythes at people doing mental math. All right, so fine. Okay, negative 20. Okay, now you try the following on your own, and I'm gonna leave it up right next to this example so you can use it as a guiding light. Okay, let's try 4 on the square root of 16 minus 3 on the square root of 64. Okay? Let's try 5 on the square root of 9 plus 2 on the square root of 81. Try those two and see how it goes. Okay? The irrational rational thing I am touching on next. Okay? So we're coming up on that real soon. All right? Now, those of you who are working this in the future, make sure to pause the video here because I'm getting ready to give the answer. And remember, I said at the start of this video, watching is useless. Like, brain doesn't keep stuff you watch. You want to watch, pause, try. Watch, pause, try. It's the doing. It's the practice. That's why we call tutoring practice at the school. Because practice is what makes the grade. That is what makes smart smart. Okay? Okay? All right. So, pause here. Practice if you need to, because I'm getting ready to give the answer. In 3, 2, 1. Here it comes. Okay. So, fine. Square root of 16 is indeed 4. Bring down your 4 times. Bring down your minus. Square root of 64 is indeed 8. Bring down your 3 times. Okay? 4 times 4 is 16. And 3 times 8 is 24. And my good friends, 16 minus 24 is indeed negative 8. Look at you, beautiful humans. Okay? Square root of 9 is indeed 3. Bring down the 5. Bring down the plus. Square root of 81 is 9. Bring down the 2. 5 times 3 is 15. 2 times 9 is 18. And 15 plus 18 is indeed 33. Look at you, beautiful human. Okay? All right. Hopefully you got that. Piece of cake. Okay? If not, rewind it, practice some more. We moving on. All right. So irrational, irrational. Okay? Here's how we do this. All right? Let's get out some different colors here. Let's get out some different colors. Let's get out some different colors. How about some purple and green? Y'all feeling that? Let's do some purple and green. All right. So here's how I'm going to teach you irrational and irrational. All right? Raw and ear. Okay? Here's a nice, easy way to remember it. Okay? I'm going to give you the real definition. Then I'm going to give you the shortcut. Then I'm going to give you the nice thing that'll last you till pre-calculus. Okay? Here's the real definition that you'll probably forget, but I'm going to give you the real one because I won't be lying to you out here. I'm going to tell you the real thing, even if it does feel complex. I don't care. It's still the truth. Here we go. An irrational number is a number that cannot be expressed as a fraction. All right? That's what it is. Okay? Now, I don't expect you to remember that definition, but that's the real one, okay? Here's how you can remember it for today. I want you to think of it like this. Any number that goes on forever and never repeats is irrational. Because if it goes on forever and doesn't repeat, then it doesn't stop long enough to be a fraction. Think about it. To be a fraction, you have to have a number to put on your paper. But if the number keeps changing, how do you put the number on paper? Irrational numbers are the only numbers that don't stop changing. And because they don't stop changing, you can't stop them in order to make a fraction. Because to make a fraction, you got to have a number. But a number isn't a number if it keeps changing. Because every time you start writing it, it's become something different. And so you start writing that, and it's become something different. And off you go forever and ever and ever and ever. Got it? So an irrational number is a number that goes on forever and never repeats. Because as you're going to see in a little bit, there is a way to write numbers that repeat as a fraction. If it just repeats and goes on forever, we can make a fraction out of that. We can make a fraction out of numbers that go forever and repeat. We can do that. But we cannot make a fraction from a number that repeats, that doesn't repeat and goes on forever, okay? Because remember, every time we write it, it changes. Forever, okay? So let's look at what that means, right? Wait, I just brain farted. What were we talking about? Okay. Cannot be expressed fraction. Okay, goes on forever, right? So let's look at this, right? 0.33333, right? 0.333, right? We can just write that as 0.3 repeated, right? That can be written as a fraction because 0.3 bar is 1/3. And I can prove that to you, besides you put it in a calculator, that that's what this is. 1/3 is the same as 3 divided by 1. And if we go 3 into 1, right? We get 1, put down your dot, and your 0. 0.390391039, you get it. This is going to go on forever, and it's never going to stop. But that's just 1 divided by 3. Got it? That can be expressed as a fraction. A number like pi, however, so this is rational. This is rational because you can make a fraction out of it. Okay? That's rational. You can make a fraction out of it. A number like pi, however, goes on forever and never stops. Never stops. Okay? This thing will go on for a long time. Oh, wait, I already did 26535. Anyhow, okay, this goes on for a long time and never stops. You can't build a fraction out of something that won't stop changing. Does that make sense? It won't stop changing. Ooh, that's actually the better way to say it, okay? So a number that won't stop changing is irrational, okay? These are numbers like we just said, pi. These are numbers like the square root of a number that's not clean. So the square root of 100 is just fine. That's 10. We know that. That's not irrational. The square root of something like the square root of 13 is irrational. It's going to crank out a number that goes on forever and keeps changing. It won't stop changing. It just keeps changing all the time. Irrational. Okay? The square root of 67 is irrational. The square root of 21 is irrational. The square root of 5 is irrational. The square root of 2 is irrational. The square root of 3 is irrational. Any square root that is not perfect is irrational because it just won't stop. It'll just keep going, and it's never enough. It just off it goes. Okay? Does that make sense? I'm going to leave it at that. Okay? The shortcut way you can remember this for your test is if it is pi or if it is a square root of something not perfect, it is irrational. There is other stuff in here, but you're not going to see it on your test. Okay? For now, I just want you to remember If it's one of these guys, it's irrational, okay? Everything else is rational, no matter how crazy it looks. Everything else is rational. Now, another thing they'll do is you may see a number notated like this. It's like 1.234 ... These dots right here mean that the number keeps changing. This right here is not the same as saying 1.234 bar, because 1.234 that bar means 1.2344444, which is fine. This is rational. This is fine because it started repeating, so you can do something with it. Numbers that go on forever and won't stop changing, like don't repeat, are irrational, okay? All right. Everything else is rational, so please don't go trying to remember what's rational. Forget all that. Just memorize these three things. Pi is irrational. If it's a square root of something not perfect, it's irrational. If it's a decimal that won't stop changing, it's irrational. Everything else is rational, no matter how crazy it looks, until later. I'm warning you. But they involve trigonometric functions and some other functions that you're not even going to blink at right now. So we're not going there. Okay? Logarithmic functions. We're not going there. Okay, anyhow. All right. I'm not gonna confuse. So, okay. So these three are what you're looking for, okay? Pi, some square root of some number is not perfect. Decimal that won't stop changing, noted, shown by all those dots. That's irrational. Everything else is rational, no matter how crazy it looks. Negative 3/2, rational. Negative 1.5678, rational. 1.46 bar, rational. 0.3 bar, rational. 1.8, rational. 10, rational. 100, rational. Banana, rational. Just got it? All right, here we go. So let's look at how to turn a repeated number into a fraction, because that's another thing that you're asking me about. Let's take 0.3 repeated. All right, here's what you're going to do. You're going to look at the decimal, and you're going to say, okay, what place is that in? So this 3 is in the 10th place, right? So we're going to write that as a fraction. 3 over 10. Okay? 3 over 10 is 0.3. But it is not 0.33333, which is what this is, right? Because that's what that bar means. Okay? That's what that bar means. So what you're going to do is you're going to subtract 1 from the denominator. And that's going to leave you with 3 over 9. Congratulations. You just made it a repeat. Done. Now you do have to simplify this. But I want you to know that's all there is to this technique. Subtract 1 from the denominator and you got it. 1 over 3. Done. That's it. That's all. That's how you make something repeated. That's it. Okay? All right, not bad. 0.12 repeated. No problem. What place is this 12 in? The hundredths place. All right, no problem. 12 over 100. Okay? We're not done. We got to subtract 1 from the denominator. So we're going to go minus 1. And then that's going to give us 12 over 99. Okay? Simplify it if you can. And ta-da, you got it. But Mike, got to simplify that fast. That's okay. You can take all the time you need to simplify. I just want you to remember this step right here. Determine its place. This was the hundredths place. Put it over that. 12 over 100. Subtract 1. Great. As of this step, you are officially done. And all you need to do is simplify, which you already know. Okay? That's it. That's it. Done. Okay? Let's try another. 0. Let's try this. Let's try something without a 0. Let's go 12.5. Actually, let's not. Let's just master that first, and then we'll stick a number in front. 0.59. All right? Fine. What place is this 59 in? Try it. Pause me if you need to. Okay? The 59's in the hundredths place, so go 59 over 100. Okay? Great. Subtract 1. 59 over 99. Done. The end. Put it in your calculator and see for yourself. Done. Okay? That's all there is to this stuff. You got it. All right? Beautiful. Now, Mike, cool. Yeah, that was easy. But what about something like 3.76? Sorry, 3.7 repeated. Oh my God, I'm gonna die. No, you're not. Here's what I want you to do. Keep breathing. I'm just kidding. All right, I'm not kidding. Breathe, but breathe slowly. All right, circle. I want you to circle just a decimal and completely ignore the front number. Ignore that. Ignore the whole number altogether and just work with the decimal, okay? When you get something besides a 0 here, I want you to completely ignore it and work the decimal first. What place is that 7 in? The tenths. All right, let's go 7 over 10. All right. Do you need to simplify it? No. 7 over 10 is done. Great. Now you can look at the whole number. 3, stick it in front. Done. The end. Okay? Easy. Make this easy. Go in steps. Show all your steps. Show your steps. Use arrows if you need to. Show your work. All right, here we go. Let's try another one. Let's go 10.12 bar. All right, fine. Ignore this. What place is that 12 in? The hundredths. Great. 12 over 100. Do you need to simplify? Yes. Let's divide by 2. Okay. And yes, 12 divided by 2 is indeed 6. And 100 divided by 2 is indeed 50. These are both even, so let's divide by 2 again. Some of y'all are behind the screen yelling, Mike, you could have did 4 at the start. Yes, I could have. I know that. But if you go by 2s, it's easy for those of you who don't see that right away, okay? And this is the safer method. It's longer, but it's safer. 6 divided by 2 is 3. 50 divided by 2 is 25. Do you need to simplify anymore? No, you are done. Fantastic. Now, go back to that number that we left there and stick it in front. And what we got? 10. You are done. That is it. So when you see a whole number here, ignore it and work the rest of the problem like normal. Then just pick it up and drop it in front later. Okay? All right, done. All right, let's move on. All right, so that should cover you in terms of turning a repeated fraction into a decimal. Wait, sorry, a repeated decimal into a fraction. Dyslexia, okay? And, wait, where? I just saw that question. Why'd you not do 12 over 99? Oh my God! Thank you for catching me! I made a boo-boo! I've been caught! I've been caught! Prime time! That's a great question, and you are right. I've been caught! I've been caught! I've been caught! Oh my God! I've been caught! Ah! Ah! No, I don't erase the mistake. No, I don't erase it. All right, watch this. You were correct. You were correct. Hold up. Let me take a minute to acknowledge. Hold up. Let me make sure I type this. Make sure I type this. You are correct. Oof. Okay. Good job. Watch your test tomorrow. Don't do that. Right. So right here, we caught the boo-boo. Right here, that needed to be subtracted by 1. Boom. Subtract 1 because it is repeated. Great job. 12 over 99. All right, can we simplify? Divide it by 3. Divide by 3. And 4 over 33. Then drop the 10 in front. Beautiful catch. Mr. Primetime, you are ready for this part of your test because you caught it. And if you can catch it here, you can catch it tomorrow. Great job. That's it. 10 and 4 over 33. And you are done. Okay? All right. That is how we handle repeated decimals into fractions. We've already talked about irrational and irrational numbers. If not, rewind. We have talked about the square roots and what to do with them in adding and subtracting. We have talked about cube roots. Let's talk about something else that kind of threw y'all a little bit, and then I'll get to that graphing thing just briefly, and I'll get to the number line thing just briefly, okay? Whenever you see the square root of a fraction, don't freak out. Just look at it for a second. Just look at it. This is not so bad. The square root of 25 over 36, just break it into pieces. Ignore the fact that it's a fraction for a second. What is the square root of 25? 5. What is the square root of 36? 6. Put your fraction bar. You are done. That is it. You are done. Okay? Don't freak out. It's the same laws. It just looks different. Okay? Let's try another one. Square root of 100 over 121. Okay? No problem. What is the square root of 100? 10. What is the square root of 11? Oh, sorry. Doggone it. Square root of 121. 11. Boom. And you are done. Don't freak out. Take it in pieces. There it is. There it is. There it is. Okay? Done. All right? Not bad. Okay, you guys can do this. Make sure you work through it. Take your time on that test. Those of you who have Miss Lawrence, take your time on that. She is very fair on her exams. But you do need to show your work and you do need to take your time. She does have problems on there that will catch you out if you're busy doing the big no-no. Mental, hold up. Mental math. I will throw a banana at you. I will physically throw a banana. Where's Brown? Come here. Come here. I will throw this at you. Please stop bringing your banana cheese mental math out here. I hope you fail if you mental math. I actually don't hope you fail ever. But I really hope you get your butt kicked if you mental math. Do not mental math. Thank you. All right, anywho. All right, so boom. 10 out of 11 with our poo-poo banana brown. All right, here we go. Now, let's move on to, what did I promise next? Oh, briefly, we're going to talk about this number line thing. Some of you are having to estimate the square root of a decimal on a number line. Here's how you can approach that. Okay, I will say in higher math, it can be useful to kind of tell if your answer is kind of close or completely wrong. But I am going to say this. The square root of decimals are going to be exclusively done in calculators in every piece of higher math you ever do from now on, unless it goes past calculus 2 or abstract mathematics, which I did not touch. But up to Cal 2, I had zero reasons, outside of just telling if my answer was way off, to know how to calculate a square root of a decimal by hand. So get through it. I'm not going to spend a lot of time on this because you're probably never going to use it again. All right, but here's how you do it if it shows up on your test. And it is useful to know if your answer is way off or not. Okay? Here's a number line, and here's an example of something that some of you may have seen. All right. Number line, and you may be asked something like, here, let's bring this down just for a second. You may be asked something like, what is the square root of 13? Okay? All right, and then you may have, let's put some tick marks on here. All right. And you may have, like, let's say 3, and let's say 4. Okay? All right. Here's how you're going to approach this. What I recommend you do is, before you even start cranking your brain on this stuff, don't. I want you to immediately draw a dotted line through half of it. Mike, why are you making us draw extra lines on here? I'm already confused. Don't worry about it. Just focus. Draw a dotted line halfway through it, and I want you to write 3.5 there. Or whatever, not necessarily 3.5, but I want you to write 0.5 there, because this is halfway through the line. Then take the number here and just stick it in front of it. So 3.5, because that's what that is. This is the half. This is halfway between 3 and 4. So that's a 3.5 line. Guess what? Now you can try to piece together what this, or this is, because you know where 3.5 is. Mike, what do you mean? If the number is over here to the right of 3.5, then it's got to be like 3.6-ish. If the number's to the left of 3.5, then it's got to be 3.4-ish. Got it? Why is that important? Because if you can guesstimate what the number is, you can just multiply it times itself and see which one is closest to 13. So let's try it. Watch this. 3.4 times 3.4 is 6. Let's do some multiplication. 0, 2, okay, 6, 5, 1, 1. 11.56. Man, that ain't close to 13. And then you can immediately scratch that off your answer choices. Because I think they've got this label A, B, C, D. So you have to answer it like A, B, C, D, multiple choice, okay? Those of you who have this worksheet, you know what I'm talking about. So you can scratch that one off. Well, what about this over here, right? What about A, Mike? Could that be it? Well, think about it. First of all, if you look at this as close to 3, so you can say this is about 3.2, but you don't even have to multiply that. Why? Because if 3.4 was 11.5, then you already know 3.2 is going to be less than that. So you ain't even got to waste your time. It's wrong too. Got it? You can use logic to figure this out, just picking out a few numbers. So let's try 3.6 to see if it's the one closest to square root of 13. Okay? 6. Put your 3 up here. 21. 0. Go 8. Okay? This is just fast multiplication. You can do this on your own. If you need to, just pause. 12.96. Wait, did I do that right? Oh my God. I sure did. That's pretty darn close to 13. 3.6 is pretty close. Let's try 3.8, because this one is really close to 4. Let's see what happens when we do 3.8. 4, 30, 0, 4, 11, 4, 4, 4, 1. Boom. 14.4. So, you can see that C is the correct answer for this. How do you know that, Mike? Because 12.96 is really close to 13. And 3.8 pushes it over 13. So that can't be the answer. So get that out of your face. This has to be the answer. How do you know that for sure, Mike? Because this one couldn't be it, this one couldn't be it, this one could be it. So this one must be it. But do you know for sure it's 3.6? No, you don't have to. Because you started with your middle line. That's why I told you to start with it. See? And on these, he's not asking you for the exact answer. He's asking you for the estimate, or they're asking you for the one closest to it. Okay? You shouldn't see a lot of these, but if you do, that's how you attack it. If you're not sure, go back and rewind, because I'm not going to work on another one of those because it takes a while. Okay? Rewind it, walk through it step by step, see if you can understand the logic, use it tomorrow. Draw your halfway line, and use logic to figure out what the numbers are, multiply them times themselves, see which one's closest. Mark them off as you realize which ones are obviously wrong, whatever's left is your answer. That's how you work it, okay? Rewind it. We got to move on. Okay, how do we do the thing with the boxes, Mike? I don't know what to do with those freaking boxes, all right? No problem. Let's look at the boxes real quick. Those of you who had this before, you know what I'm talking about. Broop. The one with the grid. We're going to go blue for this. All right. Let's say you have the square root of 20, and they say they want you to approximate the answer, okay? All right, and you got the box thing. Here's what you're going to do, all right? You're going to pick the square root closest to 20 without going over. That's the game. So 4 times 4... Wait. Yo, pencil? Apple Pencil? Hello? No, did the program freeze? I think the program just froze. Okay, there it goes. Wait, why isn't it writing? Hey, wait. Oh, I unscrewed the pen. Okay, we're good. We good. Okay, woo! All right, square root of 16. Let's do it in different ink. Square root is, okay, square root of 20, right? So fine, 16 is pretty close to 20. All right, so that's a possibility because 4 times 4 is 16. That's pretty close to 20. Let's try 5 times 5. 5 times 5 is 25. That goes over 20. Remember, the game is to get as close to 20 as you can without going over. So 25 breaks it. and 16 gets as close as it can without going over. All right, so let's go with 16. What do you mean let's go with 16, Mike? I'm about to show you. Okay, what I want you to do is, once you realize 4 times 4 is 16, and that's as close as you can get to this number without going over, I want you to count 1, 2, 3, 4 boxes down, then count 1, 2, 3, 4 boxes like this, and draw your square. Okay? Here's why you're doing 1, 2, 3, 4 down and 1, 2, 3, 4 across. Here's why. Watch this. Because that is exactly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 boxes. That's why you're doing it. And watch what happens. What I want you to do is write the number 16 inside. Circle it. Okay? All right. The next thing I want you to do is subtract 16 from 20. So 20 minus 16 is 4. I want you to write that over here and put a bar underneath it. Okay? Then I want you to count the boxes on the outside of this. So go 1, 2, 3, 4, 5, 6, 7, 8, 9 in an L shape, just like that. That number goes on the bottom. And the square root of 16 was 4, right? I want you to stick a 4 here. That is your answer. Okay? Those of you who have this, you know what this is. This technique has helped a lot of you. If you have never seen this before, then you probably don't have this tomorrow. Ignore this. But if you have seen this before, this has helped a lot of you if you take it just like that. Okay? Let's do another one. The square root of 101. Okay? Remember, the game is to get as close to this, as close to 100, or as close to this number in here without going over. Okay? All right, yeah, we sure will. We'll do repeating and terminating. Sure will. Okay? All right? The goal is to get as close to this number without going over. All right? So fine. 10 times 10 is 100, and we know 11 times 11 is 121. 121 goes over, so we're not using it. We're going to use 10 times 10. Okay? So I want you to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes down, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over. Remember, when I make my boxes, I do double up on that one in the corner, okay? All right, and I want you to write the number 100 in here, because that is 100 boxes, okay? Then, remember, I want you to subtract this number from this number. So what is 101 minus 100? And that should indeed be 1. Put your bar. Now we're going to count the boxes on the side to figure out what number is going to go down here on the bottom. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21. Remember, you're going to make an L shape around the box. Okay? That number goes on the bottom. Then you're going to stick the square root of this 100 in front of your fraction. Ta-da! Now I challenge y'all who have a calculator to put this in your calculator and see what comes out. If you put in 10 and 1 over 21, you're going to get a number that is very, very close to 101. That's why this technique exists, so that you can use fractions to express an imperfect square root. Okay? All right. If you didn't understand it, go back and watch the video again. Except don't watch it, try it, okay? I'm going to give you one more practice problem to work so that you have something to kind of tell if you got this. How about the square root of 10, all right? When you finish this, the square root of 10 should come out to 3 1/7. Okay? That should come out to 3 1/7. Make sure you work it to see if you're right. Let's do another one. Let's do the square root of 54. When you work this, your answer should come out to 7 5/15, which should be 7 1/3. Okay? All right? Make sure you work that. See if it comes out clean. Okay? And, yeah, then you're good to go if it does. Okay? All right, great. All right, let's move on to our question, which is repeating and terminating. Okay? These are just big words. You actually have already seen this. You've seen this way earlier in our lesson today. So, oh, wait. Did we do single? I think we did these lines. All right, let's go up here. Remember when we were talking about rational and irrational? Okay. Repeating. Yeah, no mental math. Thank you. Repeating is when a number literally repeats itself. It's the same thing over and over again. That's why it says repeating. Terminating means to terminate something, as in for something to stop, for something to end. You've probably heard of like Terminator. It's like a company that kills bugs. It's called Terminator because it ends the bug's life. It ends. Technically, all whole numbers are terminating because they don't go on forever. They stop. For example, 1 is terminating because it doesn't keep going. 1.2 is terminating because it doesn't keep going. 1.2, 3, 4, 5, 6, 7, you know, whatever number that is, gobbledygook, blah, 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 blah. 5 is terminating because it stopped eventually. Repeating doesn't ever stop. And you would know this because it would have a bar over the number. It doesn't ever stop. And remember that pi, our irrational number, and the square root of these ugly numbers, square root of 13, sorry numbers, y'all ain't really ugly, okay? I'm just saying, you're just a lot. You're just very dramatic. These dramatic numbers are non-terminating. What does that mean, Mike? Think about it. Read the word. Non, as in not. Terminating, as in stop. Non-stop, which makes perfect sense. Because we said earlier that irrational numbers never stop and also keep changing, okay? But terminating means that something stops, okay? So 1.5 should be terminating. And because it's terminating, it is also rational. Because remember, irrational numbers go on forever and keep changing, okay? So as long as you know what an irrational number is, everything else is rational. So this is rational because it's not irrational, okay? How about 1.6 bar? 1.6 bar, right, which means 1.6666666, continue on that same trend, is, you got it? Repeating, because it keeps repeating itself, and rational. Wait, what do you mean, Mike? Why is it rational? Because it goes on forever, but at least it's repeating itself. If it repeats itself, it's still rational. It has to go on forever and not repeat itself. Okay? The official math term for that is, it is non-repeating. As in, not repeating. Okay? Got it? Non-repeating, non-terminating. Not repeating itself, not ending itself. So cancer, basically. Because cancer does the same thing. I'm just saying, like, it's DNA that's broken and doesn't have the same brokens, and it goes on until you kill it. Or it kills off some sequence it really needs. Anyhow, okay, so fine. Let's go 1.4567. Okay? This is terminating and rational. Everything that terminates has to be rational. Because in order for you to be irrational, you have to go on forever. And not repeat. Okay? Alright, hopefully that answered that. Last thing I'm going to touch on is going to be very fast because 1/3 divided by 5/4. I want you to take the second half of that and flip it. So I want you to go 4/5. Then I want you to do times. Now you good. Okay? 1 times 4, 4. 3 times 5, 15. The end. Done. Okay? So this is how you're going to do your dividing fractions. You're going to take the second half, you're going to flip it, you're going to multiply it, then you're going to go straight across. Done. No problem. Okay? Here are some practice problems for you. Okay? Take a minute to try it if you're working these. About to give the answer. All right, here we go. 2/3 times 8/7. And this should be 3/2, remember to circle them, times 1/4. And then just go straight across. 16/21, 3/8. Done, done. Just like that, no problem. Now, if you need with adding and subtracting fractions, I got another video on that. You need to go see that. I'm not doing that again here. That's what that video for. So go find it. Because there's plenty of practice problems in there, but the short version is you're going to change that denominator, the bottom of the fraction, so they're the same, and then you're going to just add them up like usual, okay? Go look at the video. It's in there. Alrighty, guys. That is what I got for you tonight. Hopefully, this is helpful to you. That is exactly an hour. That is squares, fractions. Oh, we didn't do combining like terms. Ah! Okay, here, let me show you that real quick. Let me show you that real quick. Whew. All right, let me show you that real quick. All right. When it comes down to combining like terms, that literally means what it means. You only combine things that are the same. So 2x plus 2 is 2x plus 2. That is it. Okay? There's nothing else to do with that. 2x plus 2 plus 2x is not finished because I see two things with x's in it. And anything that has like terms, literally, like terms means they look alike. Two things that have like terms have to be put together. Okay? So 2x, I'm going to rearrange this and put them next to each other. Okay? All I did was move the stuff around so the stuff that's the same is next to each other. Because now it's much easier to see. 2x plus 2x is 4x. Okay? The reason is you just add the numbers in front and leave the letter alone. Leave the letter alone. Just add the numbers in front and leave the letter alone. So 2x plus 2x is 4x, and plus 2 stays plus 2 because it's not an x, so you can't do anything with it. The end. Okay? What about this? 2x plus 2x plus 2y plus 2. No problem. What things are the same? What things are the same? So fine. You go 2x plus 2x because those two are the same. So that's 4x. Is x the same thing as y? No. I know it's a letter like y, but is it the same letter? No. Then leave it alone. So we're going to bring down 2y. Is y the same thing as a regular number? No. So we're going to leave it alone. And boom, you're done. That's it. We're just touching the letters that are the same. And letters and numbers are not the same. And remember, when you're adding these or subtracting them, you do just the numbers in front. Okay? But Mike, what about 4x squared plus 2x plus 3x squared plus 2y plus 3 plus 2? No problem. Okay? Let's find the things that are the same and stick them next to each other. Let's circle this. Let's circle this. And then let's just rewrite that first. Let's go 4x squared plus 3x squared plus 2x plus 2y plus 3 plus 2. All I've done so far is I took these two things and put them next to each other, and then I just copied this, copied this, copied this, and copied this. That's all I've done, okay? The reason is making it nice and clean where we can actually read it. All right, 4x squared and 3x squared are the same. Why? Because they're both x squares. X squares are not the same as x. They don't look the same, so they're not the same, okay? When we say look the same, we're talking about the letter there. The number in front of the letters, we're just going to add. The letters and whatever's attached to them are what we're comparing. So x squares are different than x, which is different than y, which is different than regular numbers. Okay? Take a hard look at the screen right here and let it make sense to you. Okay? All right. So fine. Let's go 7x squared plus 2x plus 2y plus 5. But Mike, wait, there is no but Mike. 4 plus 3 is 7x squared. I was like, wait, what? And then 3 plus 2 here at the end is 5, okay? All right, that's how you work these. We're out of time, so we don't have time to go into a lot of detail on that. But you want to combine things that are alike, okay? You want to combine things that are alike, all right? Okie dokie, guys. Good luck tomorrow. Kill your test. I wish you the best. I'm dizzy, so I'm getting out of here. I just been talking a lot. All right. Y'all have a great night. Good luck on your test. You can do it. I know you will do it. And y'all come see me and need help. Okay? Come see me. I'll schedule in and we'll get something done. Alrighty. Good luck tomorrow. If this is helpful, let me know in the hallways or something. And heck yeah, prime time. You for sure gonna ace that test. And y'all have a good night. I'm gonna keep sipping my Wawa. All right, good night. Peace out. Insert cool exit here. We're gonna come up with something cool to say at the end of these. I don't know what. Y'all need to tell me what to do. Y'all need to tell me what to do. I mean, I can figure it out, but you know, like it'd be cool. Like it's whatever. We'll come up with something cool to put in here. All right, good night.